Welcome to ternary operators in Python. Today we'll discuss about ternary operators, their syntax, and how to implement them using tuples, dictionaries, and lambdas. We'll also observe nested ternary operators and talk about what we did before ternary operators. These are compact conditional expressions that test a condition and evaluate it. Using them can result in shorter code and also make it more readable since they read quite like English. You can do this with if-else. We have two variables 2 and 3 holding the values 2 and 3. If 2 is greater than 3, print 2, otherwise print 3. 2 is not greater than 3, so it prints 3. If we write this with the ternary operator instead, just one statement suffices. Print 2 if 2 is greater than 3, else print 3. So it prints 3. Isn't this easier? Ternary operators follow lazy evaluation. This means the first thing they do is evaluate the condition. If this is true, they evaluate the first expression. But if the condition is false, they evaluate the second expression instead. For the times there are multiple conditions in a statement with ternary operators, it evaluates the conditions left to right. Here's a little hint. This will be useful when completing the assignments for this week. A statement with a ternary operator looks like this. If you're familiar with C++, this is how it looks there. But this isn't Pythonic. Also, colons already mean other things in Python. This code generates two random numbers, then stores the one with the greater value in the variable res. Finally, it prints the value of res. Let's check what the two numbers are. As you can see, the second is greater here. We can also implement the ternary operator using tuples. Take this code. It returns this value. So what happens here? 1 is greater than 2 is true. But is this the value of 1 or that of 2? Let's modify the statement to tell us that. Here we use f strings to tell us which is which. Let's run this. As you can see, it prints the value for 1. 1 is greater than 2 and it prints the value for 1. This means the first value in the tuple is the value for false and the second one is that for true. One limitation of this technique is that to access an element from a tuple using its index, it must first build the entire tuple. This means it evaluates both expressions. We can prove this. How about this one? Condition is true. Now it prints 2 if the condition is true, else it prints 1 by 0. This could have raised a zero division error for the 1 by 0 part, but it does not, because it does not even evaluate that. Since the condition is true, it automatically prints 2. And this one? The condition is true, so it should print 2. But like we saw, it must first build the entire tuple. This means it also evaluates the part 1 by 0 and then raises a zero division error. Another way to implement ternary operators is to use dictionaries. This code, again, takes two random numbers and compares them. If the first is greater, it prints the value for the key true. Otherwise, it prints that for the key false. Here, 1 is greater, so it prints its value. Since we're using keys to denote the values for true and false, we don't have to follow the order of false and true as we did with tuples. We can also implement ternary operators with lambdas. This code here uses two lambdas to print the values, and you can see the condition and the parenthesis to make a call. Without the parenthesis, this is a function. Like we said, we can also nest or chain these operators. This code defines a random number. If it is less than 0, it prints less than 0. Else, if it is greater than or equal to 0 and less than or equal to 1, it prints between 0 and 1. Else, it prints greater than 1. It prints between 0 and 1. Let's check the value of 1. This is indeed between 0 and 1. So, what did we do before we had ternary operators? We used booleans. Like we said in the previous lecture on operator precedence, short-circuiting is a powerful and handy tool. 2 and 3 have the values 2 and 3. Pay attention to this part. 2 less than 3 and 2 or 3. This gives us 2. Let's see how. 2 is 2 and 3 is 3. It checks, is 2 less than 3? Yes, it is. This gives us true and 2 or 3. This is the same as 2 or 3. Now it checks 2. If this is false, it would have given us false or 3, which is the same as 3. But suppose 2 is 0. This would give us true and 0 or 3. This is the same as true and false or 3, which is false or 3. This would give us 3. This is a problem. So this method does not work for the case A is equal to 0. 0 is smaller, yet it would give us the value of 3. What now? Well, we used if-else logic here. Make a call to say hello if say hello returns a true value. Else print by. This prints hello while evaluating say hello, but since it does not return anything, this prints by. Say hello or by first prints hello when evaluating say hello, then prints by because say hello does not return anything. Ternary operators are certainly useful in Python. Can you think of one situation you would use them?